At this very moment, while you're watching this video, a machine floating 1,000,000 miles from Earth is staring at a single point of light in the constellation Leo. That point of light is so faint your eyes could never find it. Even most telescopes on Earth struggle with it. But this machine is not most telescopes. It is the most powerful eye humanity has ever built. And for the past 3 years, it has been quietly pulling secrets out of that tiny point of light. Secrets about a planet 124 light years away. A planet with the right temperature for liquid water. A planet that may be covered by a single planet-wide ocean deeper than anything that has ever existed on Earth. And a planet where, in 2025, scientists detected something in the atmosphere that on our world is produced by only one thing: life. When the results came in, the lead scientist did not describe them the way researchers usually do. He called the moment profound. Within hours, headlines around the world were asking the same question. Have we just found life on another planet? But here is what those headlines did not tell you. Here is what happened after the cameras left. Because the real story of this planet is stranger, messier, and far more important than the version that went viral. It is a story about the most promising world we have ever found, about a scientific fight that broke out behind closed doors, and about a discovery hiding underneath all the noise that almost nobody is talking about. A discovery that quietly makes this planet the best chance our species has ever had to answer the oldest question we know how to ask. Are we alone? Stay with me, because by the end of this video, you will understand exactly what the James Webb Space Telescope found, what it did not find, and why the next few years may change everything. I'm your name, and this is your channel. Subscribe now if you want more stories like this, because we are just getting started. Let's go back to the beginning. The year is 2015. A space telescope called Kepler, already crippled by mechanical failures and running on borrowed time, is limping through an extended mission that NASA calls K2. Kepler's job is simple in theory and almost impossible in practice. Stare at thousands of stars at once and watch for the tiniest flickers. When a planet passes in front of its star, the star dims. Not dramatically. We're talking about a change so small, it's like watching a streetlight from miles away and noticing when a moth flutters past the bulb. In that flood of flickering data, astronomers find something orbiting a small red star cataloged as K218. They name the planet K218b. At first, it's just one entry in a list of thousands. Another distant world, another data point. Nobody holds a press conference. Nobody writes a headline. But this unremarkable little entry carries 3 properties that will eventually put it at the center of one of the biggest scientific debates of our lifetime. First, its size. K218b is about 8.5 times the mass of Earth and roughly 2.5 times as wide. That makes it a sub-Neptune, a type of planet that doesn't exist anywhere in our solar system. We have small, rocky worlds like Earth and Mars. We have giant gas worlds like Jupiter and Neptune. We have nothing in between. The galaxy, it turns out, is full of in-between worlds, and we understand almost nothing about them. Second, its orbit. K218b circles its star once every 33 days. Around a star like our Sun, that would place it deep inside a furnace. But K218 is not a star like our Sun. It's a red dwarf, smaller, cooler, dimmer. And around a star that faint, an orbit of 33 days lands the planet in a very special region of space, the habitable zone. The band of distance where a world is neither too hot nor too cold, where water, if it exists, could stay liquid. Astronomers call it the Goldilocks zone. Third, and this is the property that changes everything, K218b transits. From our exact line of sight in the universe, the planet passes directly in front of its star. And that alignment, that pure cosmic coincidence, means we can do something extraordinary. We can read its atmosphere from 124 light years away. Here's how that works. Because once you understand this, everything that follows will hit differently. When K218b crosses in front of its star, a tiny fraction of the starlight passes through the thin shell of atmosphere wrapped around the planet before continuing its journey to us. Every molecule in that atmosphere, methane, carbon dioxide, water vapor, anything, absorbs light at its own specific wavelengths, its own fingerprint. So if you catch that starlight and split it apart with enough precision, the missing wavelengths tell you exactly which chemicals that light passed through. Think about what that actually means. Light that left a star in the constellation Leo around the year 1902, before your great-grandparents were born, crossed 124 light-years of empty space, brushed through the sky of an alien world for a few minutes, and then kept traveling for over a century until it fell into a telescope built by human hands. And written inside that light, in a code made of shadows, is the chemical recipe of another planet's air. That's not science fiction. That's a measurement we can actually make. In 2019, the Hubble Space Telescope made the first attempt, and researchers announced they'd found the signature of water vapor in K218b's atmosphere. It was the first time water had ever been reported on a habitable zone planet outside our solar system. And it put this quiet little world on the map. But Hubble, as legendary as it is, was never built for this kind of work. Its instruments could only see a narrow slice of the light, and some scientists argued the signal might not be water at all. It might be methane. The data simply wasn't sharp enough to settle it. The little planet in Leo was keeping its secrets. To unlock them, humanity would need a bigger key. And in December 2021, on Christmas morning, that key left Earth on top of a rocket. The James Webb Space Telescope is the most ambitious scientific instrument ever launched. A gold-coated mirror over 6 meters wide, folded up like origami to fit inside its rocket, unfurled in deep space 1 million miles from Earth, and chilled to temperatures colder than anything in your freezer by a sunshield the size of a tennis court. It cost roughly $10 billion and took a quarter of a century to build. Hundreds of components had to deploy perfectly in sequence, with no possibility of repair, and every single one of them worked. In 2023, astronomers led by Nikku Madhusudhan at the University of Cambridge pointed this machine at K218b, and the fog that had surrounded this planet for years finally began to lift. The results, published in September 2023, were stunning. Methane, clearly there. Carbon dioxide, there too. It was the first time carbon-bearing molecules had ever been detected in the atmosphere of a habitable zone planet. But just as important as what Webb found was what it did not find: almost no ammonia. And that absence is a clue, because chemistry tells us that if this planet were just a ball of gas all the way down, ammonia should be visible in its upper atmosphere. Something below the atmosphere seemed to be quietly removing it. One of the leading explanations is as beautiful as it is strange: an ocean. A vast, planet-spanning ocean of liquid water, sitting beneath a hydrogen-rich sky, silently absorbing the ammonia out of the air above it. Scientists have a name for this kind of hypothetical world: a Hycean planet. Hydrogen plus ocean. A world with no continents, no islands, no land at all. Just water from horizon to horizon, wrapped around the entire planet under an alien orange sky. Try to actually picture standing there, or rather floating there, since there's nowhere to stand. The star hanging above you would look swollen and red, casting everything in a permanent amber twilight. Gravity would pull on you with more than twice the force you feel right now. And beneath your feet, instead of a few miles of ocean like Earth, there could be water plunging down far deeper than our submarines could ever survive, into darkness and pressure beyond anything in human experience. If life exists in a place like that, it would have evolved in conditions we've never even been able to simulate. And here's why that matters beyond this one planet. Sub-Neptunes like K218b aren't rare. They're the single most common type of planet the galaxy makes. Our own solar system just happened to skip them. So if worlds like this can hold liquid water and support chemistry, the number of potentially habitable places in our galaxy doesn't just grow, it explodes, from a handful of Earth twins to billions of ocean worlds hiding in plain sight. And buried deep in that same 2023 data, there was something else: a whisper, a faint, uncertain hint of a molecule called dimethyl sulfide. The signal was weak, far too weak to claim anything. Most people ignored it. But the Cambridge team didn't ignore it, because on Earth, dimethyl sulfide isn't produced by volcanoes. It isn't produced by lightning, or rocks, or ocean chemistry alone. On Earth, it's produced almost entirely by life, by microscopic plankton drifting in our oceans. That faint smell of the sea you notice standing on a beach? Part of that is dimethyl sulfide, the breath of an ocean full of living things. So the team requested more time on the telescope, pointed a completely different instrument at the planet, one that reads different wavelengths of light, and waited for K218b to cross its star again. What came back in April 2025 exploded across the world. The new observations showed the signature of dimethyl sulfide, or its chemical cousin dimethyl disulfide, at a confidence level of 3 sigma, and the amount wasn't subtle. The data suggested concentrations thousands of times higher than anything found in Earth's atmosphere. If this was real, K218b's ocean wouldn't just be inhabited, it would be teeming, saturated with biological activity on a scale beyond anything our own seas have ever produced. The researchers called it the strongest hint of possible life beyond our solar system ever detected. Madhusudhan, a scientist trained to be cautious, said that however you looked at it, we were witnessing new chemical processes on a world that could be habitable. Newspapers on every continent ran the story. For a few days in the spring of 2025, millions of people walked around genuinely wondering if we'd just found neighbors. Now, before we go further, you need to understand what 3 sigma actually means, because this is where the story turns. 3 sigma means there's roughly a 0.3% chance the signal is a random fluke. That sounds almost certain, right? 99.7% confidence. But science has been burned before by signals exactly like this. In physics and astronomy, the gold standard for claiming a discovery is 5 sigma, a fluke chance of about 1 in 3.5 million. 3 sigma results die all the time. They're the universe's favorite way of teasing us. The Cambridge team knew this and said so openly. They estimated that just 16 to 24 more hours of telescope time could push the result to 5 sigma and settle the question. The finish line was in sight. And then, before anyone could reach it, the scientific immune system kicked in. Here's the part of the story the viral headlines never covered. Within weeks, independent teams of astronomers around the world pulled the publicly available Webb data and began tearing it apart, looking for cracks. This isn't sabotage. This is exactly how science is supposed to work. Extraordinary claims attract extraordinary scrutiny, and the cracks appeared. One team reanalyzed the data with different statistical methods and found that when they processed the light in a slightly different but equally valid way, the dimethyl sulfide signal faded dramatically. In the vast majority of their analysis runs, it simply wasn't there. Another group ran the observations against a library of 650 different molecules and discovered something unsettling: other, far more mundane chemicals. Simple molecules sharing the same methyl building blocks fit the data just as well. The fingerprints overlap at the precision Webb can currently reach for this planet. Dimethyl sulfide and something as ordinary as ethane can look almost identical. A joint analysis combining every observation from every Webb instrument concluded there was insufficient evidence for the biosignature claim. And then came the twist nobody saw coming. In 2024, scientists analyzing data from the Rosetta mission found dimethyl sulfide on a comet, a frozen, lifeless ball of ice and dust. It's since been detected drifting in interstellar clouds in the space between the stars where nothing lives. Laboratory experiments even showed it can form through pure chemistry under exoplanet-like conditions, no biology required. The one molecule everyone had called a smoking gun for life turned out to have a non-living alibi. By late 2025, much of the astronomy community had reached a sober verdict. K218b did not yet meet the standards of evidence for life. And if the story ended there, it would just be another cautionary tale about hype. But it doesn't end there. Because while the world was arguing about one molecule, the telescope kept watching. And what it confirmed next is, in the long run, bigger than the controversy. In 2025, a team at NASA's Jet Propulsion Laboratory led by Renyu Hu pointed Webb at K218b for 4 more transits, measuring its atmosphere with a precision no one had achieved before. The verdict from this new, sharper data was clear on several fronts. The methane is real, confirmed beyond doubt. The carbon dioxide is real. And when the team modeled what kind of planet could produce exactly this atmosphere, the answer was breathtaking. K218b is a water world, not a dry ball of rock, not a mini-gas giant. A planet so drenched in water that, according to the analysis, water could make up a significant fraction of its entire mass, possibly ranging into double-digit percentages. Stop and sit with that for a second. Earth, the blue planet, the water world of our solar system, is only about 0.02% water by mass. Everything you've ever seen, every ocean, every storm, every glacier, is a thin, damp film on a ball of rock. K218b may be water on a scale we don't have words for. Oceans hundreds of times deeper than ours, vast layers of exotic water wrapped around a distant core. The scientist leading that study said it plainly. This confirms K218b as our best chance to study a potentially habitable environment beyond the solar system. Not a maybe. Not one candidate among many. The best chance we currently have. And a major NASA follow-up, where multiple independent teams analyzed the same data side by side to see which conclusions survived, agreed on the picture of a water-rich world with methane and carbon dioxide, while the dimethyl sulfide signal remained exactly what it had been all along, a tantalizing, unresolved whisper at the edge of detection. Now, I promised you honesty in this story, so here's the other side of the ledger. Because a planet-wide ocean is only paradise if it's the right kind of ocean. The same models that allow for a warm, habitable sea on K218b also allow for darker outcomes. If the planet's clouds don't reflect enough starlight back into space, the surface could be too hot. And instead of a gentle ocean, the water would exist as supercritical steam, a crushing, scalding state of matter that's neither liquid nor gas, hostile to any chemistry of life as we know it. Some researchers argue the planet might not have a true surface at all, or could hide an ocean of molten magma instead of water. And looming over everything is the star itself. Red dwarfs are famous for their violent tempers, lashing their planets with flares and radiation, and K218b sits far closer to its star than Earth does to the Sun. Whether life could take hold under that kind of sky is one of the biggest open questions in astronomy. So no, we haven't confirmed a fully habitable planet. What we've confirmed is something science has never had before, a world in the habitable zone with an atmosphere we can actually read, carbon chemistry we've actually measured, and a massive water inventory backed by real data. Every previous habitability candidate was a guess based on size and distance. This one we can interrogate. And that's why what happens next matters so much. Right now, in 2026, K218b remains one of the most valuable targets in the sky for the James Webb Space Telescope. Every time the planet crosses its star, there's another chance to catch that century-old light and squeeze more truth out of it. More transits are exactly how the last two mysteries were solved. And more transits are how this one will be solved too. Remember the number from earlier. On the order of a single day of additional telescope time could be enough to either push the biosignature signal to the 5 sigma gold standard or kill it forever. Either outcome would be historic. Think about that. We're living in the first moment in the entire history of our species when the question, is there life on that planet, is no longer philosophy. It's a measurement. A measurement with a price tag, a schedule, and a machine already in position to make it. And Webb won't be working alone for long. The European Space Agency is preparing a mission called Ariel, designed to survey the atmospheres of hundreds of exoplanets. And NASA is developing the Habitable Worlds Observatory, a future telescope whose entire purpose is written into its name, to directly search nearby planets for the signatures of life. K218b is the rehearsal. It's where humanity is learning, molecule by molecule, mistake by mistake, how to read an alien sky correctly, so that when the day comes that a signal appears and survives every test, we'll know beyond argument exactly what we're looking at. For 200,000 years, humans looked up at the night sky and could only wonder. Every generation before us died without any possible way of knowing. And somewhere over the next handful of years, an answer about this specific world, positive or negative, is likely coming. There's one more thing I want you to carry with you. When the dimethyl sulfide claim started to crumble under scrutiny, some people called it a failure, an embarrassment. It was the opposite. A 3 sigma hint was made. The entire global community attacked it from every angle. Weak evidence was identified as weak, and the solid discoveries, the methane, the carbon dioxide, the water-rich interior, survived every single test and came out stronger. That's not science failing. That's science working exactly as designed, in public, in real time, on the biggest question there is. The planet didn't get less interesting when the headlines faded. It got more interesting because now we know precisely what we're looking at. A warm, water-soaked super-Earth 124 light-years away, holding its final secret behind a curtain we already know how to open. The light carrying the answer is already on its way. It left that alien sky before your grandparents were born, and it's streaming into a golden mirror a million miles above your head at this very moment. The only question is what it will say when we finally decode it. If this story is the kind of thing that keeps you looking up at night, subscribe right now and turn on notifications, because when the next results from K218b drop, this channel will break them down before anyone else. Drop a comment and tell me, do you think that ocean is empty, or is something swimming in it? And share this video with someone who still thinks we're alone out here, because the answer to that question is closer than they realize.